Here is our first video for Math 1332. I know you're all super excited to get started with some math. So here we go. The first thing we're going to learn about is set operations. So first you need to know what is a set. So a set is just a collection of objects, like think about things that you can put in a bucket and carry around with you. It needs to be well defined, and usually the things relate to each other. Sometimes they don't, but usually they do. So a set is a collection of things, and it needs to be well defined. And we'll talk about that in a second. And usually they're related. So some examples of a set, I could say the set of all the crayons in my house. And I could pick up all those crayons and put them in a bucket. I could say the set of numbers that are smaller than 10. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could say a set is the people in my family, so me and my husband and my 3 kids. Something that's not well defined is something, usually it has an opinion. Like if I asked you, what is a set of good books to read? You might tell me some books that you think are good, but it's not well defined because your definition of good is different from someone else's. So if you see an opinion in there, it's good or bad or old or young or something like that, that's not well defined. So you need to think about a set as just a collection of things that are usually related to each other. Most of the sets we're going to talk about are going to be with numbers, but we're going to use a few with words also just to get used to operating with the sets. So there's 3 different ways to express a set. The first way is you can use a word description. So if I asked you to describe your set and you were going to use words, you could say, this is all the people that live in my apartment, and you would say their names. Or you could say, these are all the things that I have in my kitchen cabinet, and then you could list all the things I have in your kitchen cabinet. So a word description just describes all the things. You can use a roster, and a roster is where you actually like list out all the things. So each piece of a set is called an element. And if you list out each element, then that's called roster notation. You can also think about roster like whenever a teacher takes attendance in a class, they're using a roster. Or if you think about a sports team and it's a list of everybody on the team, that's also a roster. So a roster is just a list of every element in your set. And then the third one is called set builder. And this is the kind that we use in math class whenever we're talking about numbers, because if you think about how many numbers there are in the universe, there's no time for us to use a roster method, right? 1, 2, 3, 4, all the way to eternity. And words are useful in math class, but a lot of times a set builder is going to be easier because it'll have an equation in it or something that you can look at and easily figure out which numbers I'm talking about. So we're going to talk about this one a little bit later because it has a lot of notation. So the first one we're going to practice is we're going to practice expressing sets in roster notation. So all of these are word descriptions, and I want to switch it from this word description into a roster notation. So right here we have set C. All of your sets are going to have names and they're capital letters. So set C, this is my word description, the set of US coins with a value less than $1. And I want you to make a roster of those. That means I just want you to make a list. So the first thing you'll do is you'll say C equals, and you'll open up with some braces. Anytime you use a roster notation or a set builder notation, you're going to need to use braces or curly cues, whatever you want to call those. So you're going to open with that. And then I need you to list all the things that would be in this set. So if I want to talk about all the coins with a value of less than $1, you can put them all right here. The thing with roster notation is it doesn't matter what order you put your stuff in. So if you want to start with penny, that's great. If you want to start with quarter, also great. So there are pennies. You can have a dime. You can have a nickel. You can have a quarter. And you can also have a 50-cent piece or like a $50. And then I'm going to end it with my ending little curly Q. My ending ones always look worse than my beginning ones. So here is my roster notation. So I started with a description. And then my roster is down here. I just listed every single thing that fits this description, and these, the order doesn't matter. So if you have all the same words but a different order, then you are good to go. Okay, let's try this one. Set D is the set of days in a week. So D is our names. We're gonna start with D equals, open with a curly Q, and now I just need you to list all the days in the week. So it doesn't matter what order you put it in, but I'm just gonna start with Monday and go on because that's easier for me. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And then end with a curly Q. Oh, and one thing I forgot to say, all of your little pieces need to have a comma in between so that you can separate them. Say, I have a penny, comma, dime, comma. So Monday, comma, Tuesday, comma, Wednesday, comma. Don't forget this. All right, let's look at this one. Set E is the set of even numbers between 1 and 50. So if you think about all the even numbers between 1 and 50, it's quite a few. You've got 2, 4, 6, 8, 10, 12, 14, 16, all the way up to 50. That's a lot of things. So there are some shortcuts that we can use in roster notation so that we don't have to write out every single one, and it's called an ellipses. So I'm gonna put it over here. So if you see 3 little dots in math, it's called an ellipses. And these 3 little dots mean keep following the pattern until I tell you to stop. That's what you can think of it as. So if I come back here, I have E, so I'm gonna start with E, is the set. I want even numbers between 1 and 50. So if I'm thinking about numbers between 1 and 50 that are even, the first one I'm gonna start with is 2, and then 4, and then 6. Now that you have 3 numbers, you've established your pattern. Like somebody looking at these numbers can tell what you're talking about. They know that you're doing even numbers, so 2, 4, 6. Now that you have your pattern, you can put your 3 little dots right here to say, keep doing this pattern, keep going. And then we need to end up over here at our last number. And the thing that you need to decide is if your last number is going to be 48 or if it's going to be 50. So this word right here between 1 and 50 means don't include 50. So I just need to go up to 48, and the one before that is 46, and the one before that is 44. So if you can see your numbers here, I had 2, 4, 6 to start my pattern. My 3 dots mean keep doing this pattern until you get to 44, 46, 48, and then stop. Oh dear. So there's that one. So this is a nice shortcut. If you didn't have this, you'd have to write 2, 4, 6, 8, 10, 12, 14. You would have to write like all those numbers that would take you a long time. Let's look at this one. Set M is the set of numbers greater than 0 that end in 7. So that's numbers like 7, 17, 27, 37. So I have M equals the set. Okay, now this one, is there a stopping point? Right here, I wanted to go between 1 and 50, so I had a clear stopping point. This one just says, what are all the numbers that end in 7? There's no stopping point. So that means that our ellipses is going to be at the end, and then we're going to close with our little curly Q, and it means keep doing this pattern forever and ever for the rest of eternity. So my first number is 7, then 17, then 27. So I have 3 numbers to establish my pattern, and then I'm going to say dot, dot, dot. That means keep doing this pattern until I tell you to stop. But then if you put your brace, it means don't ever stop, go on forever until the world ends. Okay, let's go to the next page. So we have some fun symbols in math class because it's a different language. So this first guy means that an object is an element. So instead of writing the words is an element, you can write this symbol and that's what it means. And then this little guy with the line in the middle of it means is not an element. So these questions are gonna have this symbol right here, and it's just asking you if something is in the set or not in the set, and you just have to say true or false or yes or no. Let's come up here. I'm trying to decide if this is true or false. So I'm just looking for you to say true or false. I don't need anything else from these problems. So R is an element of this set right here. So you need to look at this set, and there's some dots in here, so you need to make sure you understand what's happening with these dots. If it's A, B, C, and it goes on and on and on until you get to Z, you need to decide if R is in this set. And it is. So this is true. Okay, let's look at this one. 7 is not an element in this set. This set doesn't have any ellipses. There's no dot, dot, dot. So 1, 2, 3, 4, and 5 are the only elements in this set. And 7, I don't see it over here. So this is a true statement. 7 is not inside this set right here. And this one is tricky, but I put it on here because your math lab homework is going to have something tricky like this. So this says the set A is an element of the set AB. This one is false. And the reason it's false is because you don't see the curly Q surrounding the A in here, you just see the A by itself. If you saw A, comma B, if it looks like this, then this would be true. This statement right here is true. But because I don't see the curly Q's around this A, that's why this one is false. So this one's tricky, but I put it on here because you'll see it on your homework later. Okay, our next fun notation is this N. It's a bold N. Like you see, it's bold, it's like really dark, it's a capital N. Sometimes if people are writing it, they'll write it like this, like you do one line here, and 2 lines here. And it means the set of natural numbers. So here's our set right here. Let's check out these numbers. So I start with 1, and then I go up. So if you look at these numbers, there's no decimals, there's no fractions, there's no negative numbers, and there's no 0. It's just 1, 2, 3, 4, 5, 6, all the way on forever and ever and ever. So these numbers, we're going to use these to practice more set notation, just because they're convenient to work with and they are familiar for you guys. So we're going to practice using roster method here. So I need set A is the set of natural numbers less than 5. So we need to have a little sidebar here. If you haven't been in math class for a while, or you don't love math, which by the end of the semester you're going to, we need to talk about this, these 2 symbols, and these 2 symbols. So this symbol right here means less than. This one means greater than. Whenever you first learn these a long time ago, remember you might have put like alligator teeth in it to see who's eating like the bigger number. This one means less than or equal to. And this means greater than or equal to. So these symbols are going to be useful later whenever we're using set builder notation. But for right now, whenever you see the words less than 5, you need to decide if that includes 5 or does not include 5. So less than and greater than do not include the letter that or the number that you're talking about right next to it. If it says less than or equal to that number, then the number is included. But if it just says less than, I don't care about the number, I just want to get close to that number. So whenever this one over here says less than 5, I want all the numbers in this set. I want 1 and 2 and 3 and 4, but I don't want 5 because I just want less than 5. So if I'm going to do roster method, I'm going to do A equals curly Q. Natural numbers start with 1. So 1, 2, 3, and 4. I'm not going to put 5 because it just says less than. If it had said less than or equal to, then I would have put 5 inside here. With the next one, we got B. It's the natural numbers greater than or equal to 25. So greater than or equal to 25. That means 25 is going to be included in my set. Whenever I write it out like this, 25 is going to be in here because it says or equal to. We're going to have B equals. Now I need to think about the natural numbers bigger than or equal to 25. So you need to decide if I'm going to start at 1 and go to 25, or if I'm going to start at 25 and go up. For this one, I'm going to start at 25 and go up. So 25, 26, 27. But how many natural numbers are there bigger than 25? A lot. Infinitely many. So I'm going to use my trick and do dot, dot, dot. So here is the roster notation for the set. Okay. Now you have a roster notation and you're going to practice describing it. So this one, it's 3, 4, and 5. Whenever you're describing these sets, you're going to say natural numbers. Okay, all of these are going to be natural numbers if you see numbers. And then you have to decide whether you're going to use less than or equal to, greater than or equal to in your description. You can use whichever one you want. It just depends on your personality. So I'm going to show you two options for this one, and then you decide what you like the best. So if I was going to say this set for me, I would say greater than or equal to 3, less than or equal to 5. That's what I would say. I would say greater than or equal to 3, meaning the 3 is included, less than or equal to 5, meaning the 5 is included. But if you wanted to, you could say greater than 2 and less than 6. So you can say that also. It's the same thing. To be greater than 2 is the same thing as greater than or equal to 3. It's just this greater than 2 means I don't include 2 in my numbers. I just go with the next number that's bigger, which is 3. And less than 6 means everything less than 6, but not including 6, which is 5. So both of these are correct. Whichever one makes you happier is the one that you should write out. Let's look at this one. I've got 3, 6, 9, 12, and it goes on forever and ever and ever. So these are natural numbers, and you have to decide like what they have in common. What do 3 and 6 and 9 and 12 all have in common? And these are all multiples of 3. Because all of these, if I do 3 times 1, I get 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So these are multiples of 3. And because it goes on and on forever, like dot, 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 there's no stopping point. So that's all I need to say, is that they're natural numbers that are multiples of 3. And then my last one, I've got 5, 6, 7, dot, 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 110, 111, and 112. So these are, again, natural numbers. And then you got to go back how we had two choices up here. Decide if you're going to do greater than, less than, or if you're going to do greater than or equal to, less than or equal to. Whichever one you want. So I'm going to say greater than or equal to 5 and less than or equal to 112 is what I'm going to say. So for these homework problems, whenever you're describing them, it's like most of them are multiple choice. So you'll just go find the multiple choice answer that describes your set. Okay, the last thing we're going to practice is set builder notation. Set builder notation is a lot of symbols, not a lot of words. But once you get the hang of it, it's all good. So all of these have to do with numbers. And so the very first thing that your set builder notation is going to start with is the name. So like C, D, E. Oh, I forgot to name these two. So you're going to have the name and then equals, and you're going to open some braces just like earlier. And you're going to start with X and a big line. And that means X such that X is an element of natural numbers. So all of yours are going to start like this if you see numbers. So if it asks you for set builder notation, and we're talking about numbers, you're going to start like this every time. Just put it on your paper every time. And this means a number such that that number is a natural number, and then you're going to have to write another rule after that, like it's bigger than 2 or it's less than 10 or something like that. So let's start with this one. Set C is the set of all natural numbers. So let's just start with here. So we've got C equals the set of X such that X is in the natural numbers. Okay, we're going to start with that. That are greater than 100. So you're going to write the word and. This X is what is standing for like the numbers. So I need to write in math, X is greater than 100. So that means it's going to be greater than 100. And then you close your little curly Q. So it's really not that bad. If you guys can get this first part down, and then just figure out what your rule is over here, then it's not super pretty to look at, but it's not that hard to figure out. Okay, let's try this one. Set D is a set of all natural numbers. So D equals the set of all natural numbers. And, okay, greater than or equal to 2 and less than 10. So you need to be careful. It says greater than or equal to 2, so like this, and less than 10. So there's two ways that you can write it. You can write X is greater than or equal to 2 and X is less than 10, and close your curly Q's like this. But this is not how it's going to be written in your math book or in your homework assignment. They want you to combine this into one statement. So the way that you're going to combine it is you'll put your 2 here and your 10 here, and you put your X in the middle. And then, do you see right here, the little part of the arrow is pointing to the 2? Well, now I have the 2 over here, but I still want the arrow to be pointing to the 2. So it got flipped around. So it was pointing at the 2 right here, and now it's pointing at the 2 right here. And then this one, the big part, is eating the 10, like the alligator teeth is eating the 10. I'm going to keep it that way too. So this is how they want you to write it in your homework assignment. So you would have D is a set of X such that X is a natural number and 2 is less than or equal to X is less than 10. So one way that you can think about this is you can have the 2 and the 10, just put them on the outside. And then these guys are always going to be pointing this direction. So just make sure this one has a line because it says or equal to, and this one doesn't have a line because it just says less than. So let's try this one. Let's try letter C. So E is the set of natural numbers. So X such that X is a natural number and they are less than 10. I mean 100, I can read. So you're going to have X is less than 100. So here's that one. So this is the description and we did set builder. Here's the description, we did set builder. The next one is a roster notation. And we have to put this in set builder. So I'm starting at 15 and then I have this dot dot dot, so I'm going to go on forever and ever. And I didn't give this set a name. So we had C, D, E, let's name this guy F. So F is the set of X such that X is in naturals numbers, and now you need to describe this using a greater than or a less than or a greater than or equal to or less than or equal to symbol. So I'm starting at 15 and I'm getting bigger. So I want all of the numbers bigger than, and you can either write greater than 14 or you can write greater than or equal to 15. I like to use the 15 because it's what I see. I see 15. And sometimes if you use 14, that gets a little confusing because you don't see the number 14 over here. Here's this one. But if you want to write X is greater than 14, you can, that's right. Let's look at this one. I've got 23, 24, 25, all the way up to 29. So I have a starting point and an ending point. Let's name this guy G. So G is a set of all X such that X is a natural number and, okay, so this one, let's use our shortcut. So 23 is my low number, 29 is my high number, put X in between. I'm including 23 and I'm including 29. So I'm going to go like this for both of those. And then don't forget to close it with a brace, little curly Q. So there's that one. Let's keep going. And now you have to read roster notation and switch it into, or sorry, you have to read set builder notation and switch it to roster method. And if you can do all 3 of those different switcheroos, you're good to go. So I have a set, all my numbers are natural numbers, and X is less than or equal to 100. So if I want to do a roster, you have to decide where's your first number. So think about all the numbers less than 100 that are still natural numbers. The smallest one is 1. And I want to catch all the small numbers. So I want 1, 2, 3, all the way up to 100. And remember, we're going to use our ellipses because we don't have time to write all the numbers up to 100. And then you need to decide if you're going to include 100. And since there's a little line under here, I do want 100 in my list. So I'm going to go 98, 99, 100, and close my braces. Okay, this one is natural numbers, but I'm in between 70 and 100. The 70 has a line underneath and the 100 does not have a line underneath. So stop before you start writing and think, what's the smallest number you're going to write and what's the biggest number you're going to write. So if you said the smallest number was going to be 70, you are good. So 70, 71, 72, get your pattern started. And then dot, dot, dot. And then 97, 98, 99. We're not including 100 because it doesn't have a line underneath the symbol. It just has a less than, so I don't include the 100. The next thing you need to worry about is the empty set. So the empty set is also called the null set, and it looks like this. It'll either be braces with nothing in between, absolutely nothing. The number 0 is not an empty set. There's got to be nothing in there. Or you can use this symbol, which is a circle with a line through it, meaning there's nothing here. So all you have to do is just recognize the empty set. So on this homework problems for these, it'll just say, which of the following is the empty set? And you'll just click like, yes, that's the empty set, or no, that's not the empty set. It's just a yes or no. So let's look at this one. This one has braces, but it has something in between the braces. And the empty set has nothing in between. So this is not the empty set. Nope. What about this one? Does it look like this or look like this? No, that's not the empty set. What about F over here? That's a yes. Okay, these other three are, you have to think about it a little more. This one is the set of all squares with 3 sides. So can you think of a square that has 3 sides? Neither can I. So this is a yes. This is the empty set because if I ask you to bring me all the squares with 3 sides, you can't bring me anything. There's nothing that satisfies those rules. Let's do this one. The set of all numbers less than 7 and also greater than 25. Can you think of a number smaller than 7 and also bigger than 25? And if I ask you to bring me all of those numbers, your bucket would be empty. So this is the empty set because I can't be less than 7 and greater than 25 at the same time. Okay, and let's look at this one. This is a set of x's where we have natural numbers and all my numbers are less than 0. So if you think back to natural numbers, are any of them smaller than 0? They're not. So this is also an empty set. So on your homework, it's just a yes or no for empty sets. Okay, we're almost done, you guys. Keep going. So now we have the cardinal number. So the cardinal number, if I ask you for the cardinal number, it might say cardinal number. It might also have this little notation right here, n of a, and that means the number of things inside set A. So it's just how many things are in the set. All you have to do is count them up. So let's look at set A, and we're going to find the cardinal number. And all you have to do is count. So if I look at this set, I have 1, 2, 3, 4. So the cardinal number of A is 4. That means there's 4 things in my set. What about over here, B? How many things are in my set? Did you get 1? Because you should have. Okay, this one's a little trickier. I've got 13, 14, 15, and I'm going to keep following that pattern until I get to 22 and 23. So this one, you still need to count. So I've got 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's 11 elements in that set. Okay. What about for D? What do you guys think? Did you get 57? Take a minute and count that one out if you want to. Down here, we have some set builder notation. I need natural numbers between 1 and 6. And you need to look at this notation and decide, are we including 1? Or are we including 6? Because of these little symbols have lines underneath it, we are going to include 1 and 6. So I need 1, 2, 3, 4, 5, and 6. So the number of elements in this set right here is 6. There's that one. Okay, let's look over here. This one, my numbers are in between 30 and 35, but they don't include 30 and 35. So that's just 31, 32, 33, and 34. So the number of elements in set F is just 4. So you need to be careful with symbols that look like this and symbols that look like this. Make sure that you're being really careful with them. The last page for 2.1. Okay, here's 2 more words that you need to know. You need to know equivalent and equal. So in English, equivalent and equal mean the same thing, but in math class, they don't mean the same thing. So equivalent in math class means that you have the same number of things. Like if my family has 3 kids and your family has 3 kids, our families are equivalent. If my crayon box has 8 crayons and your crayon box has 8 crayons, our crayons are equivalent even if we have different colors. But to be equal, they have to be exactly the same. Same number and same elements. So same elements. So same number, same elements. So if I have 3 crayons and they're red and blue and yellow, and you have 3 crayons that are red and blue and yellow, then we are equivalent and we are equal. So in math class, they mean 2 different things, which I know is sort of confusing. So we're going to decide if these 2 sets are equivalent and if they're equal. So if I look here at A, this one has 3 elements in it. This one has 3 elements in it. So that means that these are equivalent. But if I ask myself if they're equal, I need to know if the elements are the same. So do I see the same exact numbers in this set as I see in this set? These are not the same, so they're not equal. So they have the same number of elements in the set. They both have 3 numbers, but they're not the exact same number, so they're not equal. Okay, let's look at these colors. 1, 2, 3, 4. There's 4 things here. 1, 2, 3, 4. There's 4 here. So yes, these are equivalent. And then you need to decide if they're equal. So I've got red here, blue and blue, green and green, black and black. So yes, these are also equal. So remember, in roster notation, order doesn't matter. So they don't have to be in the same order, but I have to have the same thing in my container. The last thing we're going to do for this video is talk about finite and infinite. Okay. Finite means that you can count it. Or you can say countable. Infinite means it's not countable. There are infinitely many things in there. So if it's a finite set, I can find its cardinal number. I can say there's 10 elements in this set. There's 12 elements in this set. But if it's an infinite set, I can't count them all up and tell you how many there are. There's infinitely many things in the set. So we're going to decide if these guys are infinite or finite. So if I ask you to list all the students in our class and then count them, could you count them or not? I can count all the students in our class, so this is a finite set. Okay, let's look at this one. The set of numbers between 1 and 1 billion. So if I listed all those numbers, 1, 2, 3, 4, all the way up to 1 billion, could I count them? I can. It would take a long time, but I can count them. So this is finite because I can count them. What about the set of numbers bigger than 2? So 3, 4, 5, 6, 7, all the way forever and ever and ever and ever. I can't count these because there's no ending point. So this is an infinite set. Okay, let's look at this one. 1, 3, 5, 7, 9, forever and ever and ever and ever. This one is also infinite. Because there's no stopping point, so that means I could never count them all up. This one, 5, 6, and then I do some stuff, and then 120, and then 130. Could you count all of those? You could. This is finite. I'm not asking you to count them, I'm just asking you if you can. And then this one, I need natural numbers where the numbers are greater than or equal to 5. So you need to decide if I can count that or not. You cannot because it's starting at 5 and it's going up forever, 5, 6, 7, 8. So this one is infinite. Okay, you guys finished your first video. Go do some homework.